Please let's welcome Senior Researcher at Microsoft Research, Eric Horvitz.
Okay, it's an honor to be here. It's a wonderful symphony of innovation today that I've been listening to. These are very exciting times for us with computation, memory, of course, sensors and connectivity, but the glue which will release and enable many new kinds of services is going to be in the learning and reasoning prowess, and we've seen incredible gains there in the last 15 years. I'd like to think about a lot of what we've seen today and we see going on in the world as the proliferation of intention machines. Machines that can take sets of observations in and then take actions and provide services that are in line with the prediction about intentions of a user, also provide feedback. An example is web search with queries, content, and ads. We're also seeing a sister set of systems I call preference machines, where some signal about preferences is learned and processed, and then, for example, products and content can be provided in line with that preference. An example we've heard about today is collaborative filtering, where you have a set of preferences. Usually it's n, not 3 dimensions here. Things aren't usually scattered like this. They're actually clustered. And when someone new comes in, for example, to a website or to a service, we have a good sense for the things they might be interested in. Several projects today have been focused on a really great area, and I think about that Memorex commercial with the speaker blowing the hair back. We're going to talk about this topic here. Geocentric collaborative filtering, combining location data with time, for example, and making predictions about locations and services based on this kind of fingerprint. We've already seen great research going on, our lab and others, where queries at different locations, even for the same phrases or terms, can be shown, if you do some IP lookup, to mean different things if you cross that with time in particular. For example, MSG might mean Madison Square Garden in the evening in New York. A big theme in our team and several teams at Microsoft Research is streaming intelligence, the idea of continually sensing, learning, and reasoning, and making available services in life, both in the back end as well as up front with the local device. Let me talk about several projects in that space right now before we break today. In a collaboration with John Crum, we've been taking some data that John may have mentioned when he spoke a couple of years ago and predicting destination and route. So we have about maybe almost 7 years of data now. We gave out GPS devices to Microsoft employees and their spouses and rewarded them with a lottery for a little prize. And over time, we end up with quite a bit of GPS data that's donated to our research. And we have about, now it's about 700,000 kilometers and many tens of thousands of trips. Predestination was part of the infrastructural work we've done on predicting future destinations or your current destination given partial trajectories as someone drives along. We observe a little bit about where they're going and start narrowing down where they're coming, where they're going to by inferring a probability distribution over future spaces. One key piece of evidence is called driving efficiency. For every square, doing a Bayesian analysis, we backchain and say, would these be coming here, driving in that efficient way or inefficient way? And right away, that one piece of evidence can be used to do quite a bit of inference. But we combine quite a few more pieces of data, including prior probability distributions over where you've gone before, things like ground cover, trip times, and so on. Even an open world model to predict new locations that have been seen before. Call it open world reasoning. The current system, at about halfway in a trip, can give us a 2-kilometer error on the destination. when you have this kind of technology, and there are other research more recently that's layering on top of this in other centers as well as ours, you can imagine multiple applications. Of course, there's all the commercial applications. If I have a probability distribution of where you're going, I can think about giving you great advice about how to travel. I can think about partnering and providing services for third parties that might want to offer coupons of various kinds and various kinds of services like this. Let me talk about a few services we can build based on that kind of reasoning. One is the realm of opportunistic planning. I like to cite John Lennon here. Life is what happens while you are busy making other plans. The idea here is with mobile commodities, a system that Ajay Kumar and Chris Meek collaborated with me in a group a couple summers ago. And the idea is to achieve goals opportunistically in the context of a current plan. So here you're going someplace on the green trajectory here, and you want to reason in the background about this red dot that might satisfy a standing goal or interest. Do an economic analysis of time, actually get a sense of, build a machine learned model for how costly time is right now, and actually have an infrastructure for doing either fixed priced or dynamic auctions at the back end. So we want to consider time and distance and have a model that searches through and finds opportunities of various kinds. So we built a nice architecture here and fielded it and played with it. The idea is you can set preferences on a client and then have the system reason over time and decide if, when, and how to let you know about interesting offers provided, for example, by third parties. Let me just give you an example for fuel purchases. Here you are in your car. You told your system, whenever I'm down 10% fuel remaining in my tank, I want you to help figure out where I should get gas, but consider my time. That's really critical, and distance and so on, what I'm doing right now, where I'm going right now. We can use predestination as well as stated times to take a live feed of fuel and location and then do some reasoning. Let me show you a little bit about the experience here. Just a simple example. Now, imagine right now that this is going on in the background in the cloud as you're driving along, going someplace. The system recognizes you need some fuel. It's doing a search for waypoints, dynamically doing a cost-benefit analysis. And of course, fuel is just a simple example. And it finds the best trade-off, really taking into consideration your preferences. And it actually designs a path for you that gets you back onto your pre-planned course, as well as with pricing information. Now, of course, you can go on that with coupons and so on as well. Another space we're looking at is eco-computing, applying computation to challenges to the environment. And this is a significant area of investment for us on our team, several teams. It's a really promising area. The problems here and the opportunities include efforts going on to make hybrid cars better by giving them GPS data and terrain data to understand how to control the microstructure of how they're, for example, using electric and the fuel-powered energy sources, as well as coming up with eco-optimal paths, given options. Now it's not just fastest and shortest, but we have eco-friendliest that might combine several of that attributes together. We mentioned one that I'm quite fond of, ABC, Agent-Based Computing Project. This is again with Ajay Kumar. The idea is we heard a lot about instant and planned rideshare, and there are some services out there that do this kind of thing. We're very interested to get a sense for building an end-to-end infrastructure, taking real data, several thousand commutes of Microsoft employees, and see how this would all work. What you see here is, in blue here, is several thousand AM commutes to Microsoft in the Seattle area. The width of the roads there is the number of trips on that width, that length. And the idea is to say, let's put some really formal models that can reason and optimize given two people, for example, person blue and person purple here. People have different preferences and needs, which might be represented as cost functions. Start time, how costly does it start earlier? Starting later, how long, what's my tolerance for a trip duration, for example? How about arrival time? What's the calendar look like? Can I come in later or earlier? And then the idea is to actually take these different needs and do a decision analysis dynamically at the back end. Find the best settings for crowds, and then plot plans and distribute them. So here's some actual data of some people anonymized here. And we want to do some crowd cost-benefit analysis and source that into a system that could take information about predestination, as well as planned departures and arrivals, or just calendar information from an Outlook calendar add-in. Do that search in an ongoing manner and find best trade-offs. And it considers CO2 kilometers of extra time, for example, cognitive cost of driving versus not, duration of trip, and of course shifts in start and end time. The idea is to actually do planned commutes as well as instant commuting requests, like 15 minutes before the start of a trip. Let me show you a little bit of how the system works here. We're coming in right now on a day with real traces. This is like real Microsoft commute data right now. And ABC is operating right now in instant rideshare mode. People are coming in with 15-minute requests for rides 15 minutes in advance of the need for their trip. The green here is our trips in progress that have been matched already by the rideshare system. The bright red are paths that could not be matched well per optimization here. The blue you see showing up here, the blue blinking on, is our new rideshares that have just been formed and queued with everybody getting directions and driver assignments. And the light pink are requests coming in, being queued up in the lower right-hand side. It's beautiful to watch this system work because you really see how technology plus location data plus preferences and machine learning can really be very, very useful in the future as we begin to compress resources like car use. And then eventually, and I was telling Sebastian through this, as important as having automated cars someday running around, let's say in microtransit in a city center, we also want to have these systems to actually optimize in an ongoing way that usage. So you order up your car, and in the back end, the system is figuring out who's going where and what kind of constraints and so on. The system also comes complete with a payment model that is fair. It does Victory auctions, Victory-style auctions. So here's the AM commute you saw before. We run the system on it, and we see right away we can do an analysis of what it means to reduce the load on the highway system and the driving. We also can now, since everything's numerical, preferences go numerical, we can take preferences about social relationships and have the system warp paths and warp its costs based on social information, even going to sources like Facebook and having people use an app in Facebook to give us parameters for that rideshare system. The other thing that's kind of fun to do is the notion of showing the world how powerful this is by doing what-if studies. So we often say, well, what would happen if more and more people in Seattle would use the system? What does it mean for savings? And do you get a gelling effect or a phase transition at some point in time? And we actually see, for example, that the efficiency or how much savings you're having, 40% savings on total number of commutes, for example, going into 50% as a function of going from 100 to 500 to 800 drivers, as a function of the log of the drivers. To actually do this analysis is a lot of fun and can be quite motivating for people that can actually build and make such a system available and apply those kinds of resources that you need to do that kind of thing. Let me talk a little bit about forecasting and alerting, another whole area. And I saw people touching on some of these ideas in a variety of fun and exciting projects. The idea is to learn from streams of data. We've done a bunch of work on traffic, which I'll just dwell on for a little bit here. I've always been intrigued about how traffic, if you're in Seattle, I guess I spent a number of years at Stanford, and I thought we had it bad down here, but you haven't seen anything until you've gone to Seattle. So Seattle was a great test bed for traffic studies. The system, there's been a lot of people fighting the traffic system over the last few decades, so it's a very hardened system that doesn't stress well with the stresses it receives. Doesn't flex well, I should say. And the idea was to actually see if we can learn from sensors in the highway, incident reports by doing some natural language processing analyses, weather and major events, for example, among other streams of data, to learn a model to predict what's going to happen with the highway system, for example. And we did that with Bayesian nets or graphical probabilistic models here. But the idea is people carrying around their smartphone can look up and see how long it will be with a little clock here for any different parts of the freeway that show up on that system. How long until a clog will melt? That means 10 minutes. Or how long will an open threatened part of the arterial system close. Those are green discs. I also give a little bit of information on the error in the inference and so on. Now, we could talk a long time about SmartFlow, as that application was called, and its usage. We did a lot of logging of how it was used and so on. A lot of fun. Let me just focus on one aspect, because I think this is kind of a real fun direction for thinking about the future of intelligence in the cloud as you walk around with your devices or without your devices someday. And this is the idea of learning what surprises people and having a device that helps you deal with unexpected surprises. So we took a model of traffic that a human forecaster would have based on some standard things that are shared or observable, like time of day, day of week, weather, and so on. And looked at the real-world outcome of the traffic system for every major portion of Seattle's traffic for the highway system. And then we sort of said, let's take 15-minute segments of time by time of day and day of week and learn what's kind of the standard expectation. Like, for example, I never go home from Redmond to Kirkland on 405 North because it's always crowded. Why would I even want to, I know that I don't need to look at a device to tell me that. Well, maybe devices can be smart about what they tell me. So we actually built a database of surprising events that would surprise a human being. And we had so much of these human surprises, we can apply machine learning to that. And what's really kind of fun, and this is for unexpected flows, like 405 North is actually wide open at 5:30 p.m. on a Thursday evening, or clogs where you didn't expect them. And we took a lot of detailed observations of dynamics over time and sporting events and weather and accident reports and so on. But instead of looking at machine learning about now, we said take a surprise and go back an hour, go back 30 minutes when things sort of look normal, and learn to predict a future surprise. And then make that available with models that run surprisingly well as an overlay that sort of look like this when you're using your phone. This means surprise now, things are really clogged, which is not that useful. This is more important. You'll be surprised in 30 minutes that will be wide open on your trip. So we combine this with predestination, that where you're going prediction, or with your plan to go home in the evening. You can set up in the system your AM, PM commutes. And all of a sudden you can say, well, just tell me, don't bother me otherwise. I'm not going to even look at this application. You can buzz me when you think I'll be really surprised by my commute or where I'm going right now. Now, I like to think that someday you'll take a device out and it won't just be traffic. You'll walk around and you'll say, where will I be surprised next? About anything you care about. That's the future, I think. But it was really fun to see how people use this tool. We fielded it a couple of years ago, and to watch the surprises and watch how people react to it over time. Now, sticking with traffic for just a little bit here, I say that our Manhattan project at Microsoft Research in machine learning has been the ClearFlow project. Whenever I say that, the marketing folks say, Eric, can you please call it a moon mission when you're talking to the public? I said, sure, moon mission. So the idea is to basically, we do a lot of work on highway system, and typically in major cities like San Francisco, Boston, New York, Chicago, LA, the highway system there's been investments made in making sensors work at the highway system. And we've all think about the idea of going beyond that someday with devices, crowdsourcing, and so on. The prediction challenge that I was very interested in, and this happened to me after I got off the freeway that was backed up a few times, and I ended up even worse off on side streets because everyone had the same sort of idea, or maybe it was bad to begin with, is to predict not just a few streets, but all streets, flows on all streets in a greater city area. And then if you had that, to route with A-star or Dijkstra through that and provide custom-tailored routes based on the actual context. And what we did was we took a bunch of the MSMLS data, we got new data from GPS devices around Seattle. We made a deal with the buses, the metro system in Seattle, to take data off the bus system. And what we're actually doing, and this is how it all works, we're taking the highway system, which we have years of sensor data on, weather, major games and events, and now we're using the crowdsourced, you might call it, or the GPS data to weave a predictive model together that lets us use these available sources like highway flows and predict streets based on many, many properties of streets. What kind of divider do they have? What are they near? How far away from the on or off ramps, and so on. This is a segment of one of the models we built, but you can see we're combining at any moment in time many different types of relationships and observations. So we built Clearflow internally at Microsoft. People used it for about a year and a half, 2 years. We did a bunch of evaluations on it. It was kind of fun to run the system internally. We'd show people what Clearflow would do and what MapPoint would do, the default system being used in the world, and side by side. And we also let people click a little button and show them the Clearflow and the MapPoint estimates of the route of each other's routes. So you see, in general, MapPoint is very optimistic about the world. Oh yes, no problem, and so on. And in fact, the Clearflow route's not as good. But on the other hand, our system that learns about all these roads understands a little bit more deeply what's really going on. About a year ago, we fielded Clearflow in 72 cities in North America. So I love the fact that every 5 minutes, 60 million streets across North America in these cities are being updated with a Bayesian model that's learned from data and that's routing people around the world. You can Clearflow just on maps.live.com. You can use Clearflow to route based on traffic. It's fun to see some of these examples that the testing group came up with to show me. Chicago, the Kennedy Expressway is really in bad shape. Default system. Clearflow learns to pull away by understanding basic topologies and flows, and then cross quickly and so on. So let me just finish up with a project here that I think you'll find very interesting. And this is related to this, where am I going next, and so on. And this is a very important area of predicting presence and availability. So for about 5.5 years now, I've had the Coordinate server monitoring me, and with other people at Microsoft that are part of the system here. Coordinate looks at my comings and goings, my GPS data, my use of all my devices, including my mobile devices, and it lets developers, to start with, internally, write general interfaces and general SQL queries. So you can ask Coordinate, how long until Eric will be back in his office for 15 minutes, given that he's been gone for an hour and 10 minutes, and his calendar says these things. So that's a service, a general service. We relay predictions. And so this is one little app that kind of you can view into what's going on here, but you see here it says that I will next read email in over 3 hours here. I'll be home in quite a while. I'll be on a network computer in a little bit over 2 hours. Office presence in 50 minutes. When will I be video conferencing available, and so on. And the expected cost of bothering me now with a phone call. 83 cents in this case. People can also look at this little probability for any prediction, like reading email, for example. When will I next read email? Look at this prediction. Lots of applications came out of this. For example, I share out with some close colleagues an app or authentication privileges that lets them, when they put my name in Outlook and expand it, they can see, let's say for Paul, they can see that, well, I was last online 5 minutes ago. I'll be online again in an hour and a half. I was last in Outlook 6 minutes ago, but I'll read email within 19 minutes. We've done studies of how this changes when people even write an email. It's interesting to look at and think about. We also have Coordinate also has a model of the cost of interruption that's personalized to me, learned from watching me over time and from some forms I filled out, as well as for any meeting, whether I'll attend that meeting or not, believe it or not. So in the past, we had a bunch of fun applications that were kind of traditional. And Brady actually was visiting us for TechFest this year, and he actually liked this application, wanted me to show it to you people here today. And this is the idea of taking this project we're doing on building a kind of a unified presence to work in a kind of an anthropomorphic way with people. And we have male and female characters. We got a complaint we were being chauvinist recently with our female gender receptionist. But the idea is the system actually understands people and scenes and works in different situations. We have we Well, I'll show you. I think it's fun this is the background. I think it's really fun to watch this.
We have some more headcount coming on.
So this is a receptionist demo.
That's great.
She's playing the role of a Microsoft receptionist. The red dot is her gaze.
Hi. My name is Laura, and today I'm here to help the receptionist with shuttle reservations. What's your name?
I'm Dan, and this is Eric.
Nice to meet you. Do you need a shuttle?
Yes.
Which building are you going to?
I forget, where are we going?
I think it's building 9.
You sure?
Yes.
So, you're going to 9, right?
Yes.
And this is for both of you, right?
Yes.
I'm making a shuttle reservation for building 9 for
So
2
who has the
people.
slides?
In case you want to correct anything, say or press star over.
So,
Are you visiting someone?
Okay,
Yes.
So I think
I'll
everything should
help
be
you
all set.
register in just a moment.
fabulous. Thank you.
Okay.
I think we're set.
Okay.
Excuse me, sir.
Yes?
You will be on shuttle
So
53.
she's modeling attention,
It
pose,
should be
and
here
so
any
on.
second.
All right, thank you.
So this has been it's an interesting project in integrative AI, taking pieces like machine learning, and inference, natural language processing, vision. The trend these days is that there's been a sort of a splitting or a separation of AI, even into different conferences. And several of us, Andrew Ng at Stanford, our team, we're seeing what we can learn by piecing components together, like Receptionist here. Let me just say what we did with the system. That was the general platform we built. We took Coordinate, made the system Coordinate savvy, and now we have. If you visit me at Microsoft Research, that's my office over here, you'll be greeted by a system that's sitting outside my door that's become my personal assistant for scheduling services. And so there's a few videos here. Let me show you one running out of time here. This is how the experience looks.
Hi. Are you looking for Eric?
Yes.
He is currently in the meeting. I expect him back in about 2 hours.
Okay.
Would you like me to send him a note or schedule the meeting for you?
Oh, let's schedule a meeting.
Okay. Please swipe your badge so I can get your calendar information. Got it. Let's see. Give me a second. Unfortunately, it doesn't look like there's any good 1-hour slot for the next couple of weeks.
Oh, wow.
How much time do you need with
Well, I just need something really short.
Okay. Tell you what. If you stop by around 2:45 p.m. today, I think I will be able to pencil you in between 2 meetings.
That's great. That's great,
Okay.
thanks.
I'll make sure to let him know when he returns.
All right.
So that system is accessing 5 years of data about me, including GPS data. The other demo, which I want a chance to run right now, she's on wireless. She sees me on wireless, and she sees me just leaving a meeting across campus. It can tell people about when I'm going to arrive, and make apologies, and then to email me and so on. I'm going to stop now, but I have to say that privacy is a very, very, very big deal in our area. You've heard some nice talks today and some technologies. There are 2 that I'm very excited about that we're pursuing: community sensing and PSP, where you do all the machine learning and sensing on local devices in the domain of the user and get quite far with that without sharing stuff out to the cloud necessarily. And it's a whole story there. But since we're running over, I'm going to stop now. Thank you very much.